If you find these videos helpful, please. All right, let's get started. Hi, my name is James and welcome to a Bald Engineer live stream. We're going to be doing some soldering tonight, and so should be a pretty easy, chill, relaxed, whatever day it is. First, welcome to the live stream. If this is your first time, my name is James, I'm the Bald Engineer. And you could be watching this on YouTube or Twitch or Facebook, so welcome. The good news is, wherever you are, if you chat, they all come together and show up on screen, like right here. Dr. J says it's Thursday. Okay, I'll take your word for it. Thank you to everybody that said hi in chat. So I think I saw Thomas, Babin, Dr. J, Crafty Nerd. Good to see you. Okay, so what are we doing? We've got, if you remember, we designed a circuit board in KiCad, and those circuit boards have come back. And so originally I wanted to solder everything using my reflow oven. However, not all the parts are in yet, and I'm not confident they're going to be here until Saturday or Monday. But I'd like to get some soldering done. So we're gonna solder these boards, and then we're also going to make a serial cable because we're going to need that for the stream tomorrow night. Tomorrow night we're gonna use an Apple IIgs, and we're gonna play some educational games, which are not actually games, but they're electronics simulation stuff. So I thought that would be fun. Okay, so with that said, I'm just gonna start to dive in. What I'll show you on the laptop is, let's go this way, and here, let's open up the circuit that we're going to be working with, because I'm going to need it anyway, so I can see what parts go where. MOSFET test board, and I recognize some of this screen might get obscured. The only thing you're missing is a screw hole. There's nothing too important. So let's see, what we're gonna end up doing is we're gonna put on a screw terminal. We're gonna put in some header pins here. I'll go ahead and solder in the, what do you call it? MOSFET. And then on one board, we're going to put in I take that back. We're not going to do that. We're going to leave these free. Down here, we'll put in header pins, and then we're not going to put in an up or down resistor yet. Not going to put in the capacitor. The sense resistor we don't have. We will load the LED, and we'll put a 0 ohm resistor on one board and something like a 1K resistor on another board. And then next week, when we get the current sense resistor, we'll be able to hook everything up and make measurements. So I think, let's get that out of the way. I think we're good there. Let's go ahead and do we'll go this way. And I need this guy. And we've got 3 boards, but we're only going to populate. Yeah, we're only going to populate 2 because I need the 3rd board for something else. But we'll go ahead and get 2 of them done, and then we can chat while we do all of this fun stuff. So let's see. Let's go overhead main, and I'll make sure you guys can see this. Hey Samuel, nice to see you. Welcome to the stream. All right, kind of put that there. And let's see, for these boards, we're going to be able to, we'll put that on last so that we can slide this in. And then when I go to do everything else, we can just clip on like this, I think. I just want to test to see if this is going to work. Yeah, we're going to be able to make that work. I'll focus that here in a second. Okay. Now, the other thing we need are some components, because otherwise, what's the point? So I have the transistors, so we're good on that. And then I have my magic black book, which I guess non-nerds would have phone numbers in theirs. And for those of you who don't know what a phone book is, that's where we used to keep our phone numbers. So we're going to need, let's see, I've got some green LEDs. So let's pull these out. Come on, there we go. So green LEDs, and then I should have a 0 ohm resistor in here. A 0 ohm resistor. I hope that's 1206. Looks like it. I can't remember now. Is that what we made these? I don't see. Yep. Everything's 1206. Perfect. We are locked down for 15 days. Yeah, this is my 4th week of lockdown. But I don't want to dwell too much on that. There's enough people talking about that stuff. We don't need to. I mean, we can, but let's do something more interesting and more fun, which is like, soldering stuff. Got an idea. I have an idea. So where are we on right now? B-roll main, transform, edit transform, and then let's crop this. Let's go like 200. Perfect. And then we're going to move this over. There we go. That way we can see more of what I'm actually doing. Okay, I think that's all we really need, right? Because we're going to do a LED, and then we'll do a 1K resistor. So I thought I know I have some of those. Now, if you were here for the stream last week, one of the streams last week, I was all out of 1K resistors. Oh, are you kidding me? What? Oh, come on. I must have put 1Ks in here. Well, unbelievable. So I've got a couple of 2.2s. We'll do that. these are just for indication anyway. It's just funny because I do actually have surface mount 1Ks. They're just in a storage box that I don't want to go get into right now. Just kind of cracks me up that here we are looking for 1K resistors again. Go figure. Okay, so what did I say? Diode 1K. What is R2? R2 is going to be the 0 ohm, and then we'll put in the transistor. Perfect. Did you put the design files online for us kids at home to play along with? Shucks, I should have done that. Tell you what, I really like that idea, and it'll take all of 5 seconds. So let's do that very quickly. We will do a, let's open up GitHub. 0 ohm is kind of contradictory, but it's really helpful because it allows you to have places to, what do you call it? Basically places to create where you want different paths to go. And like in our case, we want to be able to test the circuit with a 0 ohm and without a 0 ohm. So we can do that. Yeah, the interactive bomb for KiCad, I thought about using that today, but I haven't used it before, and I don't want to get too bogged down in that. Oh, what did I just do? See? I'm easily distracted. So what are we calling this? Let's just call this MOSFET characterization board. Characterization board description. Bald Engineer / AddOhms live stream board. Close enough. And this is going to end up, let's go, do I have to give it a directory? I don't think so. License, we'll put it under MIT. We'll ignore for the moment because I just want to get this created. Okay. Well, I don't really care. Okay. Now, what I'll do is let's go and close this. Have you guys look at my face for just a moment while I go into secret directories. Go where this is located. MOSFET test board. And then we'll copy all of these. Oh, I guess we don't need these temp files or the backup files or the step file. Okay. And now I can go back to my GitHub directory. And we'll do a new folder called, what should we call it? What do I normally call it? Hardware? Yeah, we'll just call it hardware. Paste that. Okay, close this. Come back to the GitHub. And now we can resume our regularly scheduled program. All right, first commit. And we will commit that to master. And publish. Do not keep it private. Publish. Okay. Awesome. Now, you're probably wondering, where is it? Okay, I will show you. It's going to be at github.com/baldengineer. Repositories and MOSFET characterization board. So you should be able to find it. All right, and let me actually go and look to make sure there's something in here. Okay, should be good to go if you want to download and take a look at the files yourself. And yeah, that should work. Cool. If you have questions, let me know. Let's go back to the KiCad. Load this guy back up. Yeah, actually for, so PRC, was it PRC? Yeah, so the other thought I had about the interactive bomb thing is we're only doing a couple of parts and I didn't actually label them on the schematic. So I don't think it really makes sense to use it for this one. So let's go here. Let's do this. Oh, wait a minute. Oh, I forgot. I'm missing a foot. Let me go off camera for just a second while you guys download the files. Because I did find this the other day and I couldn't remember what it was for. Much better. It goes right here. Thanks for sharing the files. You are welcome. And if you guys remind me after the stream, I'll get the code for the trivia up there as well. I keep meaning to do it and I just don't. And I guess I could. It's pretty fast. I was going to do some cleanup of the code before I do it, but I think I'll just commit it and let you guys make fun of me. All right. So let's see now. How am I going to do this? I want to get the surface mounts done first, and I'd prefer if we just do it using this guy. Oh, there's the problem. All right, and then we'll just open this up so that I can actually get to it. Oh. So how's everybody's week going? Anybody working on a cool project? Keeping yourselves out of trouble, I hope. Staying safe. Everybody getting exercise? I was actually surprised. I made a comment, I think it was on Instagram, about going for a walk, and I got a private message from somebody asking if I was worried about getting arrested, and I just thought that was kind of funny. Maybe funny is not the right word. I don't know what the right word in this situation is, but it just seemed strange to me, the idea that it would be illegal to go outside and do exercise. Hey, Game Tech, how you doing, man? All right, let's lock that in. Let's heat up the soldering iron. And now that I think I've got everything I need, let's do the most critical thing of a stream, and that is get a little bit of music going so I don't go crazy. Yeah, as I say, don't go crazy. Ah, working in the office by yourself, that could either be good or bad, right? All right, so I turned on some music. Let me know if it's too loud or if it's louder than I am. Quiet. Oh, music's quiet or the office is quiet? All right. One more thing. We need flux. So let's get this going. All right, so the first thing I want to do is let's get the diode on first. No, I changed my mind because I'm right-handed. We're going to do the resistor first, then the diode. Okay, let's get a little bit of flux on here. Are those the only three we're going to do? Yeah, I think so. Okay, beautiful. So you can't sit on a bench. That kind of sucks. I do know bike riding's okay because I work for a German company, and my colleagues were talking about going for a bike ride after our conference call this morning. Well, this morning for me, yesterday evening for them. All right, so let's get these pads all tinned up, and then I'm going to and just before somebody asks, I do have a ventilation system. I do have it. It's a really nice filter for getting rid of the smoke, but then you can't hear me, and I mean, I just couldn't imagine. No, I'm just kidding. It's really loud, so I don't like to use it. And since we're only doing a small amount of soldering, the smoke doesn't, or the fumes don't bother me that much. If I was doing a really large board, then I would probably just do it off stream, and then maybe do a few components with you guys, so that I could keep the fumes out of my face. I didn't mean to do that, but since we did it, we did it. I'm also going to, I want to get one of these MOSFET pads tinned, because I think I know how I'm going to get that soldered on there. Oh, I didn't get it all out. Uh-oh. For those that might be wondering, I am using leaded solder. I still prefer it. Although, if you get really high quality lead-free solder, it's not too bad. I like working with the lower temperature. It did not take long to get the board in, no. It only took about a week. We actually, I submitted it right after the stream, and in fact the next morning I thought about canceling it because I thought there was something I wanted to change, and now I can't remember. And when I woke up, it was already assigned to a panel, and then like later that day it got shipped off. So yeah, Oshpark turned it around super fast, which is why I like to use them. Okay, that's looking a little better. All right. That's not going to work the way I want it to. Let me try tilting this, see if I can get rid of the glare a little bit. Oh, wrong adjustment. Might make it a little bit easier for you guys to see what I'm doing. Why are you tinning the through-hole pad? Because I'm going to put the transistor in on the top and tap it, and then I'm going to turn it over and do all three. So I just want that so that I have something for the solder to grab onto when I flip the board over. Okay, so we need the that is the 0 ohm. We need a 1K. I need tweezers. Those will work, and then I should have one more. Oh, there's the thing I was looking for last night. Should have one more. That is one of my favorites. There we go. And one more. Nope. Okay, that'll work. All right, so let's grab this. Get our I guess it's gonna be a 2K resistor, but that's okay. Let's bubble up this pad. That looks good. Okay, that's good. Now we'll get the other side. You know what? Until I need these, we're going to take them out. I don't usually have this thing next to me. Yes. So far all we've done is one pad of a resistor, but I got the field that we're working in prepped and ready. So now I'm going to do the other side of that resistor. Turn that up, connect those. It looks like it's already, there we go. All right, I'm going to do a blob, and then I'm going to come back with the wick later and get the excess off. The excess? I think I meant excess. Okay, so that guy's in place. Now the next thing is the LED, and what I don't remember is which one is the cathode and anode. I think. So if we look at, yeah, you're fine. All I want to see is, so the pad connects to the anode, and then the cathode connects to the resistor. So if we go back to the PCB, I'm pretty sure this is connected to there. Yep, so this is the anode, and that's the cathode, and I guess they're trying to say there's no silk screen here, so this is trying to indicate cathode, and then cathode goes resistor to ground. All right, so now what we need to figure out, go back to main. That is right in the light. Okay, so now we need to figure out on these LEDs. I'm going to get a couple of those out. So one side of the LED is marked, but I don't remember if it's the anode or cathode. I think it's the cathode. But if you look really careful, I'm holding one of the terminals. The other terminal has a green mark on it, and that green mark is something. So what we'll do is what I always double check with my multimeter, and we'll see which terminal is which. I think the marked terminal is going to be the cathode. What do you guys think? So I'm going to go for it and say cathode and anode. And then, wait, wrong mode. Although, I'm pretty sure that means it was, yep. All right, so we're getting a voltage of 1.8, and the LED turns on, which is always a great visual indicator. So that works out. So the green mark is the cathode, and so that means the cathode is this pad over here. Perfect. So we'll do this and get that one nice and hot. And now we'll do the turn to the side so that I can get access to it. Move this over a little bit. I don't like that. It's not really sitting flat. Let's see if I can get it up just a little bit more. There we go. All right. Tip is getting terrible. Let's try to clean this up a little bit. Add a bunch of solder and then wipe it. That looks a lot better. So some of you will have heard me say this many times. The tip tinner stuff that it comes in a little can or jar, you should not use that every time you solder. And so it should be used sparingly. If you can just use solder and a brass sponge, then you'll end up much better off. So it's a little crooked, but I'm going to be okay with that. The other thing we're going to do is, I'll do that after I clean these up. All right, R2, that's where I'm going to put the 0 ohm resistor. And that's these. Yeah, I'll do better on the next one. I'm not really a fan of hand soldering surface mount. I usually use my oven, but since it's so few parts, I figured we would just suffer through and do it by hand tonight. And I guess it's always good practice for when I have to do rework. Okay, let's clean that. Make sure you guys can see. Move this one over. All right, really happy with that connection. So now we're going to try and get onto here. I'm trying to make sure I don't touch the tip. I want the solder to flow from the resistor down to the tip so that we get a nice solid connection. There I actually touched it, but that's what I was going for. All right. Okay, so those three are on. We're not going to do any of these, so let's go ahead and clean that up, and then we can, I want to get all the surface mounts, and then we'll come back and do the through holes. Okay. Much better, much cleaner. Like that much better. This one's got a little bit of a bubble. Much cleaner. All right. And then we put this little enable pin in here in case we don't want the gate resistor or the gate LED to turn on. So now I will do that, and now it's good. All right. Let's get the other surface, the other board done, and then we'll come back and put in the through hole parts, since it's kind of fresh in my mind at the moment. I learned to solder using surface mount, and so I'm completely biased when I saw surface mount is quick and easy. Yeah, actually, I prefer doing surface mount. I mean, I would still rather do surface mount by hand than do through hole. I think it's much faster, it's much easier once you learn how. The problem I have with through hole is you have to get really good at flipping the board over, and that bugs me. So Eric was asking why not use tip tinner, because tip tinner is very acidic, and it's basically pure flux. It's very acidic. It is designed to cut away and really it's designed to dissolve any kind of oxidation that's gotten onto the tip. And so one of the problems with that is it wears down the iron plating or the chrome plating. And so it actually degrades the life of the tip. Now, the good news is because it's removing oxidation, the tip will be more efficient, and so that'll help it last longer. But you do have to realize that when you're using tip tinner, you're actually shortening the life of your tip. Although you're increasing the life because it gets more efficient, but you just have to be careful. So you should only use tip tinner on an occasional basis. If you get to the point where it's super, where it's super oxidized, then yeah, by all means, use it. It'll help. But if you use it every single time you solder, then you're going to wear out your tips very quickly. All right, so we've managed to lose our 2K resistor. That's kind of a bummer. Just make sure I didn't put it on the other board. Nope. Okay, well. Thanks for the tip. I see what you said there. All right. Well, 1 ohm is going to be too small. I have a 10K, that's too big. 4.7 is too big. I don't want to go get the other ones, but we might have to because can't believe I already lost my resistor. Okay, I'm going to grab it. What is that next to the flux? Next to the flux is a 0 ohm resistor. That's why I kind of freaked out at first, because I pulled out 2 of those and 2 of the 2Ks, and I got to thinking I might have put both 2Ks on the board, but I didn't. I don't remember really flipping anything up and out of the way, so I don't know what happened. That's really weird. Oh, come on. Really? For reals? I only have 805s. Damn you for 1K resistors. It's like I am cursed. Oh. Well, I don't know if you were here for it, but I've actually ordered multiple 1K resistors at this point, and I keep losing them. Now, surface mount, I wasn't expecting to run out. It's just frustrating because every time I need them, I don't have them. This would never happen with through hole, except it did. That's what's so funny about it is the other night I was building the op amp circuit and I couldn't find any of my 1Ks. I found the empty bag that they belonged in, but I couldn't find the 1Ks, which is hilarious because I have this whole big box of through hole resistors. The only reason I have all of those resistors is because I needed 1Ks, and so I bought a whole bunch of other values. But now the 1Ks have disappeared. I think whoever steals socks from the dryer snuck in and stole my 1K resistors. That's what I think happened. But all that said, I do need to order some. Let's get some 1206 1K S&T res. Okay. 1K would be 104, I think, right? Because it's or 103, because it's 1, 0, or was it 102? Because it's 1, 0, and then 2 zeros. So that'd be 1000. Because I think 104 is 10K. I guess that'd be 100K, wouldn't it? Well, let me. Yeah, because the 2K is. Wait a minute. Yeah, this 2K is 20. Well, it's 2201. Whatever. I don't actually know what the surface mount resistor code is. So if somebody wants to look that up and help out Dr. J, that would be fantastic, because then I would learn too. All right, so we fluxed it. I was looking for the resistor, found the resistor that we're going to use, which is a 3K. So these LEDs are going to be super unexciting. Let's tin the pads and then I can put that on. What are you stuck on? My ESD strap? That's not good. That's not how they work. All right, and then this one. Let's do that. Sort of the same story. Got to get enough solder on there so that it'll suck back out when I use this stuff. And try and stick this right into the hole. Yep. Nice and hot. Come back up. Did I get it? Cool. Nice plated solder through hole. All right, and then I don't know why I wicked up both pads last time. Wasn't really thinking my steps through. All right, that one's good. Come on. Basically took all the solder off. All right, nice and clean. Good, ready to go. All right, now let's see, we're doing the 3K. I guess the silk screen was just a suggestion. The interactive bombed tool would not have helped at all today because of me. Okay, so I'm looking at this from an angle. I think I got it on straight. Yeah, actually that looks pretty good. Wow. Parallax for the win. Okay. Now, on this one, did not think about this. We're going to put, I have a lot more limits on this one than I was expecting. All right, we're actually I was originally gonna put 100 ohm, but I don't think I have 100 ohm. I don't. I have 10 ohm, but I don't think that'll make big enough difference. 10K is gonna be too big. We'll just put another 3K in there. And then I need to mark these boards so that I remember which one is which. Thank you for the follow. I missed your name. But feel free to say hello in the chat if you haven't already. So yeah, so I wasn't thinking ahead. We didn't need the other 0 ohm. I only want a 0 ohm on one board, and on this board I wanted a resistor value. So in this case we're going to do 3K. So then I think I'm going to order some 100 ohms as well. Sorry, if I don't take a note, I won't remember. So the first two digits represent the significant number. Got it. And then the number is multiplied by 10 to the power of the last digit to get the oh, it's 10 to the power. So 10 to the 2 would be 100. Yeah, so a 1K would be 10, 102, because it'd be 10 times 100, make it 1,000, right? Oh, yeah, Eric already did the math for us. So is this your circuit design? Yes, it is. We actually did a stream on it a couple of days ago. I guess it was last week. It's a board that I wanted to design a board that would allow us to show what is a case when you might need to have a series resistor on the gate of a MOSFET. Because a lot of people assume that because MOSFETs are voltage controlled, that the gate resistor isn't necessary. But you generally do need a gate resistor, but it's for a different reason than why you need one on a BJT. And so in order to show why, we needed a really good, really clean, well-designed PCB so that we can hook up a differential scope probe and show the voltage drop across a current sense resistor so that we can see the current on this trace. Because what I'd really ideally like to be able to do is show the current and the voltage of the gate when we're turning it on and off. And I'm hoping when I show that you'll understand, people, not you specifically, but that people will understand why you sometimes do need a gate resistor. And then I decided, because it would just be kind of easy to throw them on here, there's pads for pull up and pull down, so maybe we could show what happens with a floating signal. And then I also added a capacitor pad so that we could maybe make an RC filter to do maybe like a soft start or something like that. And then, but wait, there's more. There's a diode pad on the back so that we can actually put a flyback diode in as well. So lots of cool little features, I think. You know, in terms of a functionality, it's just meant to play around with. So I think it'll work really well. Or I hope it works really well. I guess we'll find out next week when I get the current sense resistors. So how did I say? So it should be anode, the green line is the cathode. So we need to turn this guy around. All right. And just get this onto here. Is the PCB holder also from Willer? No, it's not. So this piece, the silver piece, is Panavice. I have a full set of Panavice stuff. Highly recommend their tools for soldering. I mean, their vices for other activities are good as well, but I've always been a fan of them for soldering. And I do have to mention that they ended up sending me a whole set of Panavice stuff. So even though I got it free, it's not sponsored, but I would have paid for it because it's really cool. And then this block was a guy at Maker Faire a couple years ago was selling them, and I bought it, but I looked up his website the other day, and it looks like he's not making them anymore, which is unfortunate because they're really nice. They're basically just, what is it, HDPE, HPDE, and then they've been mill cut, and then I was going to say bore, but the, what do you call it when you make the threads for a screw? Really great system. It was designed so you could have multiple pieces locked together, which is one reason I was looking them up, because I wanted to expand. And like I said, unfortunately, I don't think he's making them anymore. Beautiful. Okay. Well, that diode looks much better. Darn it, I can use that base. Yeah, I agree. What I did actually think about is if I can figure out if it really does look like he doesn't tat. That's what I was looking for. If it looks like he really isn't selling the design anymore, then I might scan it and at least try to, you know, it's like, okay, well, scan it and then maybe we can make them ourselves. Just realized there's T-slots on here as well, so that way you could lock them together. But if he's still making them, then I'd rather just let him do it. So, okay. I'm actually not going to clean up the solder joints on this one because they're pretty good, so I'm pretty happy with that. Hey, I recognize your name from MOSFET, from the MOSFET tutorial. Awesome, glad to hear that. Got another one that I'm working on, and I'm hoping to get that done while we're going through this period of So I've got it scripted and just haven't had a chance to shoot it yet. But I'm talking about one of the things I was going to talk about it is why you need a gate resistor. So some of this stuff might end up in that video. Okay. All right, now let's do header pins because those are super easy. So there's going to be a couple here and a couple here. Then we're going to take this guy and carefully bring him around to about here. Looks good. I'm going to grab the soldering iron, come up. You guys can't see any of this, can you? Come on. I know you want to focus. Well, that's probably as good as I'm going to get on the focus. Or maybe that is. All right. Perfect. You guys can see it just fine. I can't, however. All right, so what I want to do is just get this one in place and then grab the other one. Okay, looks pretty good. And then let's try to do the same on this one. And all right. Nope, that's the hot one. Yep, that one's pretty hot. Not liking that. Nope, 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 nope. Okay then. Now, now we can do one of these. What camera and mount system? It's a Manfrotto. I forgot what they call it. I've had that almost 6 or 7 years. And then the camera is a Panasonic G7. It's the same camera I use for all my B-roll footage. And in fact, it's the same overhead mount I use for that as well. I just, when I shoot video, recorded video, I don't let you see the mount in the frame. Can we take a peek at the schematic? Yeah, the schematic is actually, I just threw it on GitHub a little bit ago. Let me, but I can show you what we're looking at. So let's do, so here's what the overall schematic looks like, and then I'll show you the GitHub URL in just a second. I mean, it's pretty basic. So what we've got is the actual MOSFET, and then like I said, I threw a diode pad on there, although I don't really plan to use it. A shunt resistor, which is going to be used for, that's the resistor to actually measure current. This capacitor is in case we want to try to build an RC filter. Got pull up and pull downs. And then this is the current limiting resistor that I'm going to show whether you need it or not. And this is on one of the boards, we put a 0 ohm resistor, and on this board I put like 3K. But my intention was I'll swap them out with other values as well. I mean, the 0 ohm will stay 0 ohm, but yeah, so I'll be swapping that out. And then just for fun, we put a LED on the gate, and I included a solder pad so that we could enable or disable that LED in case we didn't want the current of the LED to mess up with the rest of our measurement. And then over here, you can see we've got headers for basically all the connections on the board. My goal is for the current sensing resistor, I have a differential probe for my scope that has a 0.508 inch, no, is it 0.5 inch? No, it's like, or 5.08 millimeter pitch. And so we'll put some header pins on so that we can, oh, we forgot those. Good call. So we'll put some header pins on there so that we can attach a scope probe to that. So that's what we got going on in terms of there. And if we look at, we go to GitHub. So if you go to github.com, probably the easiest thing is just go to github/baldengineer and then look for the MOSFET characterization board, and then you can download the schematic for yourself. Okay. All right. Yeah, actually, I'm sorry, I'm not going to replace it with the schematic. I mean, it's not really all that complicated. Can't really see it when it's down there, and I talk with my hands, so it's easier for me if I can do it this way. Okay, now let's go for, oh no, it's not bent, it's just, the pin is bent, but it's in there pretty straight. Okay, so I forgot I wanted to put header pins in here as well. So now those are going to be a little more difficult because one thing I wasn't paying attention to is when I did the board in KiCad, I got the pitch I wanted, but the holes are a lot bigger than I expected. And so I don't even know what's going to happen if we try to put this pin into... let's see if we grab this one. Come on. Come on. Well, that was a total fail. Should have just used pliers in the first place. Okay, 1. We're gonna need 4 of these. 3, 4. Okay. If we do here, how's that? Is that gonna? Oh, that looks terrible. I don't like that at all. The plastic is all messed up now. I mean, functionally it's fine, it just looks bad. So let's go, we're gonna go here. That's gonna be a good way to get that soldered in since I don't have anything to anchor it with. And I'd like to, well, we can easily, okay, we're just gonna have to, I know what I'm gonna do. We're going to put a little bit of solder on the hole. And okay, so just enough. And now what I'm going to do is heat it up and stick the pin in. And that should work. Alright, so I'm doing B first. 1, 2, 3. Beautiful. Doesn't look very straight. Let's try that. Okay. Yep, that worked exactly how I was hoping it would. So let's get this other one in here. I don't think that's in straight yet. Oh, God, no. Oh, that is terrible. Sorry, you're just going to have to give me a second to finish these. I don't have a good angle to get these particular points, but I'll show you what I did in just a second. So heat that back up, kind of get that. There we go. So what we ended up with, it's all cockeyed. Yeah. Okay, we'll survive. So we got these. Beautiful. All right. Now what I want to think about is, I don't know how I feel about those solder joints. All right, we're going to do the next one's different. So we're going to do the same or something similar. No, the intention for these was that I wanted to just be able to put the scope probe right onto it. What I want it to do though is, while we got the iron going, we're going to fill these in with solder. And then I might, right on the edge. All right. Reason I'm doing this is, so my single-ended scope probe has really sharp pointy tips. And so this gives me something relatively soft to poke into, but it also has a header pin adapter, so if I decide to do header pins instead, I have that option. So now what I want to do is find out if I got these spacings right. So I need to grab a scope probe. Not that one, how about this one? And find out if I have a working thingy or not. Beautiful. So that's basically what I want it to have the whole board for, is now we can get a scope probe right onto the pins. So cool. That is exactly what I wanted. All right, now let's do I guess we could do the MOSFET, because the only other thing I have left, so we'll put in the MOSFET, and then we can put in the 2 screw terminals. If I do that, it's going to make it really hard to get these put in. Let me think about that. Yeah. Okay, I'll still be able to. All right. So let's do the MOSFET, and then we'll do the screw terminals. Interesting probe. Yeah, it's a high bandwidth differential probe. So I wanted to make sure I had something that was differential, but that one has at least 1.5 gigs of bandwidth, because what we're going to end up seeing are these really fast, sharp edges. And if we just use a passive scope probe, its capacitive loading is going to actually clean it up. And then its limited bandwidth won't let us see what the edge is actually doing. And so, I mean, we're going to get a little bit of inductive effects from the pins and stuff that we're using, so it's not ideal, but it's going to be a much better measurement with that particular probe. So, now the question is, do I want to do that, or do I want to lift this up a little bit? We should grab a heat sink just to see what it will look like, even though I may not assemble it with this. But I just want to get an idea of what would it look like. So if we went all the way down, could I get this heat sink to fit in here? Yeah, that'd work fine. Okay, perfect. I think those dip pins should be soldered after SMT component. Well, the thing is, so number one, that's why I have 3 boards. I'm not going to populate one of them. For the purposes of the primary experiments that I want to do, none of these have to be populated. This is the only thing that has to be populated, which is the current sense resistor. And unfortunately, I don't know when they're going to arrive. I don't know if you guys have noticed, but if you try to order something, there's the delivery estimates do not reflect reality. So they were supposed to be here yesterday, and they're not here yet. So I wanted to go ahead and get the rest of the board soldered up, because when we do get this one, I want to be able to get right into making measurements. So the other parts are there for other ideas and other experiments that I want to do, but I don't need them right away. So I don't mind sort of closing myself out, because I've got the extra board that I can populate later. All right, is this not tight? Open this guy up. I'll turn this around, and now we'll finish off the MOSFET. It's a nice fit over the test points, almost like it was made for it. I know, right? Anytime I do something with connectors, or anytime I do something with connectors, if it's not a standard off-the-shelf connector, I always worry that I missed something in the design. And if I remember, I'll show you a board in a minute where I completely wasn't paying attention to the spacing, or the spacing of some holes, and the parts that I got will just never fit into the I think it's I made the inner hole too small, and so I'll never be able to get the part I made for it to go into it. So I was like, well, that was a waste of a board. All right, so I think that one overall looks pretty good. We'll cut the leads off here in a little bit. Put this on the ESD stuff. And now, oh, you know what we still need to do are the screw terminals. I'm actually, because I think I only have 2 of these, so I'm not going to attach anything to the gate right now. We'll use this for the gate. This was sort of, actually we didn't really need a screw terminal for that. So, hey Peter. Yeah, the boards I ordered the other day, they're already here. They actually came yesterday. And so I was really surprised. That might be the fastest delivery I've ever gotten from Osh Park. All right, so we're gonna do the same thing. Let's take this, come up here, let you guys enjoy the blurry mess while I get one of these tacked. That looks good. And then let's make sure I put this in right. So we'll do this. Heat the hole back up. Looking good, looking good. Beautiful. And then we'll go back and clean that one up, just make sure it got a nice joint going. Beautiful. So I saw you working on the what do you call it, Ice Bitsy? Did you already submit it? Or because I popped in for a little while and then I had to leave and I didn't get a chance to see if you were able to finish or not. Okay, cool. One more probe check. So this is my single-ended probe. Just want to make sure it's going to fit in between. It does. Okay, perfect. I'm actually really excited. These are working. This is working out as well as I had hoped. Oh, I just remembered what I did. I just remembered. Okay, we'll do it on the next board. Awesome. I'm looking forward to see how your boards turn out. Okay. Where are we at now? Through hole parts? Okay. Let's see. What order did I do those? I did the header pins, and then we're going to put header pins on this one this time. Do that one a little bit different. Okay, so the first thing we need are 2 header pins, and I think I'm going to leave it like this for a little bit, so let's see if we can't. There we go. Clean that up. I have 2 panelized boards in production and the Osh Park board. Wow. Man, you are just cooking on your designs. I kind of feel like a slacker. All right. Let's get this guy going. Come on, come on, come on, come on, come on. I don't think that actually took. That's okay. We'll just add more because I'm going to keep it hot while I adjust. So what I'm doing is as I get the one pin heated up, I'm using the other pin to adjust and make it nice and straight. But you do have to be really careful because obviously that pin that you have the soldering iron on is getting hot as well. And so every once in a while I kind of burn myself. But I like to have the header pin plastic right flush to the board. So sometimes a little pain is necessary. Okay. Rinse and repeat. So this is going to be one of these do as I say, not as I do. You should really use pliers, but like I said, I just kind of use my thumb. Yeah, I just realized as I said that, you know, I'm probably setting a bad precedent or being a bad role model, because I shouldn't. I sort of know how to not burn myself, and it might look like it's easy, but you do have to be careful. I'll tell you a story. When I was a kid, I worked at a Elks Lodge, and we had fish fries on Friday nights. And so for a while, I ran the fryers. And I worked with a friend, or every once in a while, my friend would come and work with me. And he always was he always like come up with like crazy ideas and games and stuff. And so he decided we should have a game where we see who could pull out the most amount of chicken from the fryer without using tongs. So I could only do maybe 3 or 4 pieces before the oil started to burn me, but he could get like 6 or 7 pieces before it seemed to bother him. And so I still think because of that, my hands are a little bit calloused, and so I tend to be able to put up with a little more heat on them. Plus all the burns I've had over the years from soldering, because I'm not good at soldering. In fact, every so often I get people asking me to do soldering tutorials, and I just don't. First, there's a lot of them out there, so I don't really feel the need to do one. But second is I'm really not that good at it, and so I don't know that I'm the right person to learn from. Like on Element 14, I did tutorials on, we did a bunch of soldering tutorials with Weller, and they were very topic specific, and so I didn't mind doing that because it was more of a how do you do things, not a if you're the first time you've ever touched a soldering iron, here's what you do. And in fact, there were multiple times in those videos where people pointed out that I did not follow IPC procedure or whatever, and it's like, okay, well, I was never professionally trained how to solder. I taught myself when I was 12 years old. Burned the heck out of myself every time I did it. And then, I don't know the professional ways. Soldering burns are the sacrifice we make to the electron god so that our circuit works. We should make that a t-shirt, buddy. That would be good. It needs to be a sticker or something. Maybe that's what I'll say the next time I solder something before we start. We'll come up with a little chant about the electron gods. Boy, I hope these are straight. I was talking the whole time I did them. Well, the heat I was feeling, it wasn't like when I did the surface mount thing and I picked up the board right after I had the hot air on it for like 10 minutes. So it wasn't quite like that. This one was more just I could feel it getting hotter. It's kind of like when you have a hot cup of coffee and you're carrying it, and after about 5 or 6 seconds you're like, well, this was a terrible idea, because you could tell it's about to burn your hands. That's kind of what it was starting to feel like. Okay, let's get that going. Did the board burn a circuit tattoo in? True story. So the one I was just talking about, that was the surface mount 555 from Evil Mad Scientist Labs, and so it happened just like I said. I had the hot air on the board for longer than I should have, and then I went to reposition the board, and I just was not thinking about the fact that it was probably that it was hot. And so it gave me at most a 2nd degree burn, but it's probably a 1st degree. And the next morning, when I was like, I got out of bed and I went and like brushed my teeth or whatever, when I grabbed my toothbrush, I was like, what is wrong with my thumb? This doesn't feel right. And it was like, what did I do? Like, I actually forgot for a few minutes or seconds that I had burned myself. And so it like a day later it was fine. So that's why I think it was definitely not worse than a 2nd degree. But I definitely felt it the next day. That was the stream where I learned I shouldn't do a soldering project. I shouldn't start a stream with a soldering project at the same time I normally eat dinner. Which is why we've been doing these at 7 o'clock Pacific time. Okay. So Moldavia, you got a 2nd degree burn on your thumb from a board? Yeah, that's... I think what irritates me, like, and especially like that time when I did that, what really irritates me about it is I know better. Like, you know, you're just like, yeah, I shouldn't have done that. And there is no undo, and you're just like, that was really stupid. Okay, that was a little more crooked than I was going to be able to tolerate. These I can just bend back into place. That's fine. Okay, beautiful. So we got this one, this one, this one. And now let's go do the MOSFET. And I'm gonna leave it blurry because I'm gonna just flip this back up in a second anyway. Oh, James, why did you put that in there already? You weren't thinking ahead, man. I put those header pins right in front of where I wanted to solder on this FET. Okay, so what we're gonna do, I put these pins. Last time I didn't put the pins in there, and so I had easy access to the MOSFET. So I'm going to come to this side of the board and hit the source pin instead. And at this point, all I'm trying to do on this side of it is I just want the part to stay in place. I'm going to resolder them on the other side, which is one of the things that somebody told me you're not really supposed to do, because I guess air can get trapped in between the layers of the via or the hole, which is something I had never heard of, but it is actually in the IPC, from what I understand, that you shouldn't do what I'm doing right now, but it works so well I can't help myself. Okay. Ooh, grabbed it right by the pads. That sucks. So I guess I'll ask the question I got asked. Did it leave a tattoo? Yeah, the reason we didn't do the reflow oven is because I realized there were only a couple of parts, and I just didn't feel like, I mean, oh, what, you dummy. I just hit the one that I was. Anyway, I didn't want to do the reflow oven just because it just felt like a lot of setup for only 3 or 4 surface mount parts. So it didn't. I even got a stencil made, so we could have done it. It was like, as I got to thinking about it, we only put 3 surface mount parts on. If I had gotten the current sense resistors in, then we would have used the reflow oven, because those are pretty big pads, and I'd rather have the oven do them. Thank you for the follow. Yeah, that's cool. I don't need a picture of your burn. That is not something I want to see. But thank you. Thank you. Where are we at? Yeah, fried chicken. That smell. Yep. All right, so I think we're ready for the screw terminal. Same story, we're not gonna put that screw terminal in. That really didn't need it. And in retrospect, I guess I could have just left it off, but that's cool. It wouldn't have saved that much money anyway. No, I want you to give me a nice, yeah. You could do better, but that's okay. You're trying, camera, and I appreciate that you're trying, even though you're not doing very well. We're all just struggling through this situation. Okay. Now let's go. We can go ahead and turn this guy back a little bit. Awesome. Well, this was easier than I was expecting. And the best part is, since we don't have the current sense resistors, we can't prove whether or not it works yet. Yeah, we can't, because there's no way to get a signal to the gate. All right. Okay, cool. So those are in there, that's there, that's there. Okay, cool. So I think these boards are as good as I'm going to get them tonight. So the idea is going to be we're going to say from an Arduino or a function generator. Function generator is going to be more fun because we can change the slew rate. We'll hook up the gate, and then we'll have the current sense resistor go in here. I'll plug in my scope probe so we can see the current going through here. And then, that's what this was for. This is, that was for the gate signal. So we'll put a scope probe on there. I don't know that I want to put header pins there yet. Maybe we do though, because I want to put the probe there so we can see the gate signal's voltage and then the current through it. We'll have to deskew a little bit, but that's okay. We'll handle that. Yeah, we're gonna go ahead and just do that because I've got a square pin header for my probe. Let's make sure that this is gonna work before I put these in here. Otherwise, it's gonna be a mess later. So if we do that, then I can do that. Perfect. Okay then. We'll go for that. Fugata asks, have you downloaded DigiKey's KiCad library or KiCad, and what do I think about it? I don't have it currently. I did download it in the past. I think it's a great idea. I wish other vendors would do the same thing. What I like about the whole DigiKey thing is, so I guess when you combine footprints and schematic symbols together, they're called atomic, and I don't remember why. And so in KiCad, most of the schematic symbols don't have footprints associated with them. And so what I like about the DigiKey library is, if that bothers you, there is a library that has plenty of usable parts that has footprints and schematic symbols tied together. And not only that, but the parts are all orderable from somebody like DigiKey. So I think that's pretty cool. I think it's a good idea to use it if you buy parts from DigiKey. I don't usually buy parts from them, so it doesn't make as much sense for me. And most of what I need is either in the default library or whatever I created on my own. But like I said, if not having footprints with your schematic symbols bothers you, or you're a DigiKey customer, then I think it definitely makes sense to have. Now, I have in the past taken parts from their library, of course on open source projects, but I just don't have it installed currently. If you guys watched my stream when I designed this board, my library is already pretty slow as it is, so I don't need to make it any worse. Did you not want to use hookup loop test pins? No, because I want to use, you might not have been here for that. Let me show you. Where did I put it? Well, it's not in the case. Oh, here it is. So for the current sense resistor, I'm going to use a differential probe, and this will plug directly on. And then same thing for drain and source. And then for the gate, I've got a single-ended active probe that I want to plug onto there. So I don't want to use loop holes on those. I could have put loops like on the grounds, and I might go back and do that at some point, but that's not what my intention was. So the idea is, here's where I was going with this, is the whole, I want to be able to measure the current going into the gate when you turn a gate on. It's going to be, it's a very small amount of energy, and so I wanted a high bandwidth probe, and I wanted to minimize my inductive effects. Granted, putting these big header pins on here, that's going to cause some inductive effects, but it's going to be a lot better than what I could have gotten with either a passive scope probe or loops or whatever. So that's what I'm going for. However, I will say, I completely forgot that I ordered like a bag of 100 of those, and so this would have been a great project to finally use them in, and I totally forgot that I have them. So, hey, Int Pirate, how you doing? You should have been here a few minutes ago. We were talking about getting burned while we solder. So, Int Pirate, one time we were doing he was doing a live stream, and he was he was doing really good, and he got to the end and he's like, okay, I'm going to turn the camera off now, but we were still on audio and Discord. Can I tell the story? I'm going to tell the story anyway. And so he turns the camera off, and we're just kind of just shooting the breeze, and then all of a sudden I hear, ow, 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 ow. I just calmly said, oh, you grabbed your soldering iron, didn't you? Yeah. It's so fun. It's like, yep, I've done that. Been there. You grab the active part of the soldering iron, and that's the end of that. Surface mount abbreviations got auto modded. Okay, I will. I'll look into that, because that's actually one of the streams. Somebody said they were talking about the 555, and they called it the 3 5s, and for some reason 3-5s got flagged by the auto mod, and I don't. That one I can't even figure out. It's like I don't. That must be some kind of like new kind of slang that the kids are using, because I don't know I don't know why Twitch got upset about that. Yeah, Moldavia, it was you, wasn't it? Oh, I didn't know there were surface mount hook loops. I would like to know what those are, because I don't have surface mount. Mine are through hole. But if I had surface mount, I would use them when I use the reflow oven for sure. Okay. Headers are on. This is in. All we got to do now is the resistor, which this board is going to be a little more difficult, but I'll manage. We may actually just use the soldering tweezers. All right. So the only other thing I got to do now is clean up the flux, and I'll do that off camera because I got to go to my work sink to do that. So we'll put those aside for just a few minutes. Oh yeah, maybe it's the SM. Okay, so I think that's going to wrap up that project, but we've got, whoa, oops, I was going to say one more. So let me just, hey, I found the other resistor. It was over here. It must have been under something. Yeah. Okay then. All right, so am I gonna need this flux for what we're gonna do next? So next we're gonna build a cable. Yeah, we'll just leave it out. I don't wanna put it away and then need it. But I don't think we're gonna need it because it's not critical. Let's put these resistors back into the black book. And these were the 3Ks. Let's do this for a second. All right. Yep. I just throw a couple of things away. All right, so that's good. Here are those 0 ohms. I want to get those put away. And then these are going to go trash. That will save. Oh, extra MOSFET. Oh, because I had 3 boards. I was just thinking ahead. Green LEDs. Let's get those put away. I don't know if they still sell it, but I got this book from Adafruit a couple of years ago. Or this binder. I mean, the binder itself is nothing special, but the pages, I forgot what these were originally for, but they fit up to 1206 strips carrier tape just fine. And so I put a lot of my surface mount parts in here. In fact, these are all my capacitors from when I worked at the capacitor company. Well, this isn't all of them. I take that back. These, no. You know what? These aren't. No, they're not. These are the ones from the capacitor company. These are the ones I got from China because I didn't have enough. Okay. That's put away. It's over here. Trash. Okay. Clean these later. Cool. Next, we are going to take this cable and we don't need that yet. And this. So what I want to do tomorrow is there's some simulation software that is kind of cool that runs on an Apple II. I wanted to check it out and play around with it. I figured it'd be fun to do on a Friday night. We could run it in an emulator or could just go straight to archive.org and run it there. Boring. Instead, what I want to do is fire up my Apple II GS and play or run the software on there. And so what I want to do tonight is build the cable we need so that we can transfer disk images over serial to the 2GS. In the event this cable fails, I'm not too worried about it because I have an SD card adapter, so we always can use that as backup. But one thing I really want to do is I want to transfer the disk image to the 2GS and then write the disk. Oh, you know what we could do? We could just use my cryoflux. Okay, well, we're going to make the cable anyway because I've wanted to have this cable for a while. But I just thought of another way we can make the disk image that would be actually kind of cool and fun. I think you guys would enjoy it. I've got a device called a cryoflux, K-Y-R-O-F-L-U-X, and it can take a disk image and write the the ones and zeros, but it can write the magnetic flux lines onto the floppy drive. And so it interfaces directly with the floppy drive, and then it tells the floppy drive what to write in terms of the magnetic data. And so what it allows us to do is it will allow us to take, say, the disk image from the internet and write it to a floppy disk using my modern computer, and then we can throw that floppy disk into the 2GS. The reason I want to do that, the reason I'm going to build this cable is I wanted to transfer the image over so that we can write it to a disk because I love the sound of the floppy drive on an Apple when it turns on because it's hitting, it's the servo hitting track 0 to make sure that it's on track 0. And I just like the sound of floppy drives. So we're totally going to, now I just realized we have 3 ways to get the programs booted tomorrow, so we're in good shape there. But let's build a cable tonight. Don't lose the resistor you just found. Okay, that's actually not a bad idea. Well, oh. Really? Because this wasn't it. This is a 0. I picked up a... Okay, well, I already lost it, so... Because it wasn't a 0. That's why it caught my eyes, because I could see that it was the... Oh. Alright, let's do this right now, so that it's somewhere that I can find later. Oh, come on. There we go. Perfect. Okay. Done. You wanted to emulate a disk drive on your C64. So Steve Chamberlain, the guy that made the floppy EMU, that's the emulator SD card reader I have for my Apples. He actually, and I have one of the boards. He made a pass-through board that is just a relay, and it detects on power up, and it makes the chatter noise that is similar to what the disk drive would have made, so that you at least get the nostalgia sound of the clack 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 when it turns on. And then what is the emulator what is the C64 emulator that, is it on the C64 or is it the Trash 80? I think it's the TRS-80 emulator that that RetroPie uses. It simulates floppy disk noises, which is kind of cool. All right. Wait a minute. Crafty Nerd is right. This was the resistor that I was looking for earlier. So then what in the heck did I just solder? Well, I had 3 2K resistors. How about that? I thought I only had 2. I think we're just going to lose this one because I don't have a good place for surface mounts. Solder some dust back from the floor. Okay, going back to burning stories. This was in college. Long story short, there was a cute girl in my class, and so she was in my normal study group, so we spent a lot of time together, but even though we were just friends, being a guy, I always still wanted to try to impress her to whatever degree I could. And so one time I was trying to show how quickly I could solder stuff. I don't know why. She was probably talking to one of her friends or something. I wasn't paying attention to what I was doing in the lab. And I picked up a wire, or I picked up a piece of solder, and I'm like, man, this solder just won't melt. I'm like, that's weird. Solder doesn't normally get hot. I wonder why it's getting hot. I wonder if there's a certain type of makeup. And right about that point, I realized I was holding the lead of a resistor, and then I ended up with like a line blister from it burning my finger because I was trying to figure out why it was heating up, and it didn't occur to me that it wasn't solder. So the life lesson I learned there was always, like when you're soldering and you go and you clip leads and stuff, always clean your leads up before you go back to soldering. Don't leave bits of wire around. That just leads to bad times. Okay. So these aren't designed to be soldered. I think this one is. Let's see. So that's definitely the pins. Yeah, so wire can go into that one, but these are solid. So I think these are meant to be crimped or something. So I think we're gonna end up using, I bought 2 different types of connectors because I wasn't sure which one was gonna work. Not with that attitude. Yeah. that was a callback from earlier, wasn't it? What the heck are all these parts? Okay, so I have one connector that is easy to assemble, and this other one which looks like a Lego project. I wonder how we're gonna do this. So this part, that part, this, that, this. Okay, so these are identical. Let's go look up the data sheet and see if there's something that explains. I don't know what all the parts do. And it seems like there's basically small cups that I think we'll be able to get a wire into. So let's see. This must clasp onto something. That doesn't feel right. Okay. This goes somewhere. That's so descriptive. No, so it looks like I was thinking this must come into here somehow. So the wire's going to come through here. And then what's the next thing? This is going to be the last, right? So does this whole thing fit inside of this somehow? I don't see like a guide. Or maybe I do, I can't really tell. So I think this comes in somehow. Oh my goodness, I can't believe we're gonna have to look up the directions for a freaking connector. Are you kidding me? Thank you for the thank you for the follow, Dr. Harma. Okay, let's look this up real quick and see if we can figure out. So I just got through saying I don't normally buy from DigiKey, and I just realized I bought these on DigiKey. I guess I buy from whoever has the parts I need. So what do we got? 2092 KMD LAX 8P ND. All right. Let's go to this. There's a video on assembly. Okay, that's scary. All right, 404 not found. Awesome, that's always good to see. You know, having that I worked for a component manufacturer, one thing we always like to make sure is that you couldn't find our data. That was always critical. Let's see what this video looks like. Press pause or rewind when needed. Okay, got it. Assemble the strain relief with the rear housing by lining up the notches. Oh. So, why do I have to do this? Didn't I buy this connector? Shouldn't this have already been done? Okay, I would not have gotten that one. Align the pin block to ensure. I didn't read it. Anyone read that? Yeah, but mine doesn't look that way. What? Push the pin block into the lower body. You'll hear it click when it snaps into place. Oh yeah, you want to bet? So somehow this goes in. Okay. Yep, crimp that. I don't think that's gonna work out. Okay. Oh, you know what? There are. Okay. Okay. So hold on. Let me. Does. Are there no player controls? Hold on. So I think what's going on is there are little divots on either side of, I don't know what they call this, the solder cup. I mean, I guess that's the solder cup, but there's little indentations on either side of this. And I noticed on this thing, it's got indentations. So maybe it's supposed to be that those line up somehow. I don't see how, but maybe that's what's supposed to happen. Or they showed some pushing into place, right? So maybe if we did something like this? No. Oh, those are not symmetric, so that can't be it. Darn it. I thought I had it. Well, there's that. That's got to be what the clip uses, right? So that has to go to the bottom. What if we did it this way? No, I don't think that's going to be it either. Come on. Okay. Hello. And yeah, loving this struggle. Yeah, this is great. This is great because this doesn't match what they're doing on there. And I just don't see how this would like have any magical interlocking connection technology things. I don't get it. It's a freaking connector. I'm still kind of baffled why I have to watch assembly instructions on a connector. I'll get over that, but it just seems like this should have come assembled like this one did, so that I could see how to put it back together. Are these the same? No, of course not. Yeah, I do the AddOhms YouTube channel, and we actually, I don't know if you meant the PCB, but the other day we designed a PCB, and it was actually this one. We haven't been able to test it though because I don't have the current sense resistor yet, so hopefully next week we'll be able to get to doing that. I think the rings hold it in place. Oh, okay, hold on. Let's see what because I'm trying to figure, I don't know what this plastic thing does, so let's see where that goes. Okay, so it goes over, seems like it went something like this. Well, what's that piece? I don't have one of those. This is just like doing Lego. And there's a spring too? What? That's the problem. I mean, first of all, there's only one metal piece, so however they're creating the total thing, we don't have that. This doesn't hold into here. I can't figure out how this sits into here. Are you kidding me? Is it just like this? Oh, maybe I misunderstood. Okay. Okay. I think I see how this goes together now. So let me come back to this. So what I think I figured out is there's a retention clip on the bottom. No, the other pile of stuff is a different connector. That has nothing. That's not. That was I bought 2 connector styles. So that doesn't. None of those parts matter. But what I realized is there's a little retention clip in here, and if I hold it against that, then these divots that I noticed earlier sort of line up. And I think what I'm supposed to end up doing is I'm probably supposed to bend something to put a retention into there. So if I follow this now, I'm glad we're doing this before we wasted time soldering to it, because that would have been upsetting. So this comes into here, but I don't understand why they have that extra plastic. Oh, no, wait. Oh, wait a second. Where is... Okay. Hold on. Sorry, I'm just gonna go for what I think this is supposed to do, and then if it works. Because I think this comes in... No, that doesn't make sense, because if it goes in this way, it's almost like this would come into here, but that doesn't make sense either. Okay. I'm very, very close to saying we're just going to have to punt, because let's see. So should end up like this. Nope. Okay. And that's the file that was missing, which is fine, whatever. Okay. I think that we're just not going to do this, because I cannot believe how over-designed this connector is. All I needed was a connector. Well, I wonder if it's missing or not, because this is the other one. So I ordered 2 of these, since I was afraid I might mess one up. And it doesn't have the pieces either. So I wonder, are we missing half of it, or is this just a newer version where it doesn't use it? So I'm just let that keep playing. I just thought of something. just occurred to me that, that's the big one. Maybe I already did have one of these and I forgot. Because I thought I had bought some at some point. So we'll just take a quick look. Nope. Power connectors, a hood for a DB9, some Pi stuff. This marker's not supposed to be in here. Ribbon cable, pieces, XLR, females. See, wrong size. That's a regular size DIN. That must be what I was thinking of. Before the surplus store in the Bay Area closed, I bought a bunch of these connectors, and I guess I didn't buy any mini DINs, but I was thinking at the time I had. Okay. Well, shoot. Yay, junkish box. Yeah, this is my connectors box, if you couldn't tell. So I've got plenty of connectors for a Commodore 64. Just don't have any for a... Just don't have what we need for this one. And what I'm going to do is I'm actually going to email DigiKey and have them reach out to the vendor and say I need directions for this one because it doesn't match what the guy's doing. So, okay. And this other style that I have, this is like a crimp or something. So we could try soldering wires to this, but I don't think I want to go down that path. If this serial cable was the only way for us to get data onto the Apple, then I would go for this. But because I realized we have another way, then I think we're just going to do that. It's not quite as fun because we don't solder something, but it'll still be fun. Check inside the housing. So this one is empty. That one is empty. And these are both empty. Wait a minute. Oh, are you kidding me? No. Yeah. Maybe it's supposed to go on. Can you see what I'm doing? What's my aperture? 3.5? That should be good enough. So what I realized is there's a little line on here. So there's only one place on this piece where, like, I can tell something's supposed to go there. So what if this goes on here, and then it sort of lines up with this part, and then this is supposed to clamp around whatever the cable is, but then then that doesn't make sense because then that's sticking way out. Or is this supposed to fit into there somehow? No, that doesn't fit. And does this doesn't fit in there. Okay. So does this fit into there? So that kind of goes in there, but then does this go in here? See, I don't see anywhere where that ground piece, because it seems like that's part of the ground shield. I don't see where it would go. Okay. Okay, we gave it a strong try. So, oh, you know what I'm gonna do real quick though while I'm got this out? Let me just take a picture so that I can attach that to the email. And then I'll just kind of do this. Kind of help myself. Not happy. All right. All right. Cool. Well, I tell you what, consolation prize. Let's at least do, I did think of one test we could do with our MOSFET board, and then we can call it a night and, you know, have lots of, say it was successful or a failure for that point, for that matter. All right, so, see, here's the other thing that's kind of weird to me is, so this is the DigiKey label, and it says quantity 2, but this is how they were packed. They were packed such that this one was inside of here, but the other set of parts were just in this bag. And so it almost makes me start to wonder, was this like part, maybe there was like a set or something and not everything made it in, because I don't get it. Or I'm just not that smart and I'm okay with that. But I'd like to know if that's what the problem is. Okay. And then this one, the problem is this needs a crimp, which we don't have. So, and that's okay. I think I knew that when I ordered it. That's why I got the other one. I just thought, let me try, you know, I bought this one just in case we had to use it, but I'm okay with this one because that's exactly what I thought it was. And I think Newark actually had a cable that had a mini DIN on it, and so maybe I'll just order one of those, or I just won't worry about it. I'll wait until I can get to a surplus store or something. Okay, here's what I thought we'd do. We're gonna take our MOSFET boards. While we were working on that, I got to thinking, the MOSFET boards have an LED. We could at least turn the LED on. Yeah, I should clean up the flux. I'm not going to right now. Instead, we're going to do the more important test and make sure the LEDs turn on. So let's grab our power supply. It's at 5 volts. If the LED doesn't turn on, then, well, then I've got 30 minutes to get to the store before it closes to buy alcohol. Okay, do this, do that. All right. Zoom as much as I can. So we're looking over here. It's either crazy magic or parts are missing. Yeah, all right, yay. Can you see it? Let me turn this off. All right, so it's lighting up, but boy, that 2K resistor is not doing us any favors. But that's okay because it's an indicator LED. It just needs to be, I just wanted it enough that we'd be able to tell when the gate is active. So, woohoo! Oh, damn it! I have a sound effect coming. Had some friends record some sound effect stuff, and I totally could have used it just now. All right. Maybe we'll work on that for tomorrow. Probably not, because tomorrow I'm going to be, most of my day is going to be spent trying to get the Apple II ready. Well, the day that I spent on this. Actually, you know what we could do? I know how to make it brighter. Yeah, it'll be fine. Let's just turn the voltage up. There we go. There we go. Nice, bright. How much current is it drawing? 6 milliamps. Oh yeah, we're fine. Off, on, off, on. There we go. See, successful stream. At least we got that good. We got that going for us, right? Thank goodness for LEDs. Okay, so we got our MOSFET boards mostly assembled. We're still waiting for the surface mount, or the the surface mount current sense resistors. It looks like those are going to come tomorrow, but if they do come tomorrow, I'm thinking Sunday we might finish this up, or no. I know what I want to do on Sunday. I keep teasing using the Nano VNA and my real VNA. I have a whole bunch of low noise amplifiers that I bought from a couple of vendors in China. They all arrived today. So I thought it'd be fun to go through and make some amplifier measurements and kind of talk RF and do some RF stuff. And so I think that's what we're going to do on Sunday. And then whatever days I stream next week, one of the first things we'll get back to is this MOSFET board. I also have, from yesterday's stream, I already ordered new op amps for our op amp circuit. I went with the two that we talked about, the auto zeroing, and then the OP227, which is the old one. And I was like, oh, I don't want that one, it's old. Well, it's a rail to rail, and it has low noise or a low offset input. So I think that's gonna work out well. And so I hope those come in next week. So we'll be able to get back to that. For now, I'm going to sign off. I do want to remind you that we do have a Discord. So if you go to AddOhms.com/Discord, then it will redirect you to the server. So if you'd like to keep the conversation going, feel free to do so. If you'd like to see an archive of the stream, head over to twitch.tv/baldengineer. I I highlight all of the videos so that they will stay up there for as long as highlights last, which right now is forever, as well as individual parts of the stream. If you haven't checked it out already, I did want to point. I'll do one advertisement, because I did have an Element 14 video come out yesterday, and I'll be darned, but I can't even remember what it was on. What was it on? It was on LCR meters. So I don't know why I did that one. So anyway, this one's kind of fun. It's talking about the difference between a DMM and an LCR. I think it's a cool one. It was really stressful for me to write it, because there was about 10 minutes of me explaining how AC circuits work. And so I ended up having to, I ended up pulling all that out because it bogged the episode down, but I'd like to reuse it at some point. And so anyway, if you want to see how an LCR meter works, go check that out. We'll probably use it on the stream at some point, so it'd be good to know. That's on the Element 14 Presents YouTube channel, or you can go to element14.com/workbenchwednesdays. All right. For now, oh, thanks, Moldavia. I'm going to wrap up. Like I said, what do you call it? If you want to keep the conversation going, head over to Discord. You'll see an ad for it here in just a second. Thanks for everybody that joined. I really appreciate everybody helping out. I'm glad we got the board going. Wish we could have done the cable, but that's cool. Got a backup plan for that. So thank you for the follow. And yeah, thanks a lot, guys. If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.